All right, so for this assignment, it's going over a lottery system where there's 6 numbers picked from 1 to 20. I'm sorry, 1 to 51, and they must match the state's pick for the grand prize. So I'm going to go through this very quickly as I only have 5 minutes. So the probability of winning it is discrete, as there are only a finite number of possible drawings. Even though it's a very large amount, there's only still a finite, and that you can find that by doing the combination. 51 numbers and 6 picks, and you divide 1 by the possible outcomes, gives you the probability mass function, and therefore the probability of for one attempt is this number here. It's very small, and Alexandra buys 1 ticket every day for 80 years with a cost of $5. How much did she spend, and was her probability of winning once? So you times the days by the years, and then multiply that by the $5 to get the total amount that she spent. And then in order to find the probability of winning at least once, there's a few steps you got to go through. First, you got to find the probability of losing, which is 1 minus the probability of winning. And then from there, you can find the probability of all the tickets losing. And then from there, you subtract 1 minus the probability of all the tickets losing to get the probability of at least 1 ticket winning. And then I printed it out here. So the cost of all her tickets is $146,000, and the probability of at least one of the tickets winning is still less than a 1% chance. It's a very small amount as well. And then for Amir, he has a number of friends that he wants to gather for different probabilities of winning. So there's 4 epsilon values, and the tickets are bought independently of each other. So that means they can repeat tickets that they are buying, like the numbers. So I made a dictionary. Actually, first I wanted to show the math here. I don't have much time to go into all the math, but it is found here. The number of friends is greater than or equal to the natural log of 1 minus epsilon, which we were given, divided by the natural log of 1 minus the probability of a ticket winning. So I did that math here in this function, and then I printed the results once I have that. So for each of the epsilons, these are the amount of friends he would need, and the 0.5 probability requires over 12 million friends, which will be used in the next question. So we were going for the 0.5 probability, and they wanted to, or actually the number of friends for the 0.5 probability, and they wanted to increase their odds without getting more friends. So in order to do that, they needed to buy tickets dependently by making sure the tickets weren't repeated. So in order to do this, I made a function here. So what I use the iteratortools.combinations method, which finds all the possible combinations of numbers for the 51 numbers when you get 6 picks. And from there, I randomly sampled without replacement so that each friend got their own tickets. And that can be seen here. I just printed a few of the first 3 of the tickets, and then you can see that the number of unique tickets by finding the length of tickets to be equal to the number of friends. So we can see that we did actually generate that many tickets for each, or that many tickets that each friend got 1 ticket, and they all are unique. And then for the next question, if we wanted, if 3 of the 6 numbers matched in order to win a consolation prize, what is the probability that the consolation prize, or what is the probability of winning the consolation prize, and what is the expected value of that consolation prize? And we want to know if that will increase sales. So there wasn't any values given for the grand prize or the consolation prize, so I just kept it proportional just to show like how low of a chance of winning the grand prize is. So I don't have time to go into the math, but it's found here. And then and I used the hyper geometric distribution and found the probability mass function of that. So I'm sorry, I misspoke that. So I found the probability mass function of the hyper geometric distribution. And then so for the expected value, we compare the probability of the consolation prize to the probability of the grand prize. And then from there, if you wanted to keep the consolation prize proportional to the grand prize, we can see just how much more likely we are to win the consolation prize compared to the grand prize. So I made a little PMF hypergeometric function here. And then I compared I just printed the probability of winning the grand prize again and the probability of winning the consolation prize. And then in order to find the comparison, I compared the consolation prize probability divided by the probability of winning the grand prize. And then I printed that out. And that is shown here. You are 283,800 more times likely to win the consolation prize compared to the grand prize. And then if you kept those proportional, and you wanted to make that the value of you would divide the probability of the grand prize divided by the consolation prize probability. And that value is very, very low. It's this 3.5 to the power of -6. So then that means, so I just did an example grand prize. If it was worth $100 million, that would mean the consolation prize is only worth $352, which is a much lower amount compared to the grand prize. So I don't think this would make people consider going for the console. Like, I don't think they would sell more tickets for that $352. You would have to make you couldn't keep the consolation prize proportional to the grand prize. You would have to make it much more valuable. And yeah,